So the third and final part of the ImageStreamGang example from Completable Futures will touch on arbitrary-arity methods, which, as you may recall, are the things that are going to work with an array or a variable number of futures in order to wait for them all or wait for any of them, and you'll get back a single future that you can then use to wait for everything else to complete. So let's see how this is going to work. So just a quick recap of the context. Remember, collect is used to create a list of futures to images that are going to be in the process of being filtered, downloaded, and stored. So those are the things that it's doing. And it's actually being downloaded, filtered, and stored, not filtered, downloaded, and stored. Not quite sure why I wrote it like that, other than maybe it formatted better on the slide. Obviously, after all this takes place, then everything would just be displayed. We're not going to focus on the display part, although it's pretty cool. So let's take a look and see how this works. So at this point, we've collected ourselves this list of futures, right? And now we're going to do the next stage. It's not even really a stage in a pipeline sense, the next phase. And what we're going to do is we're going to use something called streamutils.joinAll, which is this little helper class I wrote, in order to take this list of futures, list of completable futures to images, and convert it to a completable future to a list of lists of images. And once we have that, right, once we end up with this completable future that can be used to wait for everybody, then we simply join on that single completable future. So that'll actually finally block, right? Everything up to this point has been non-blocking. We will finally block, wait for everything else to finish, and then we're going to convert this into a list of lists of images, and then we're going to sum up the size of each of the lists in the list. And that'll end up giving us the total number of images processed. So this is just another fun little pipeline that shows how you can convert a list of lists into a stream of lists, and then you can collect everything and you can sum all the pieces together in kind of one fell swoop in a very clean and declarative way. So join waits for all the images, and this does all the summing of the list of lists, or the stream of lists. All right, so let's take a look at how join all is implemented. And this should look somewhat familiar to you because this is very similar to the finisher method in the futures collector that we talked about from the earlier examples in your assignment 3B. This is just now pulling a piece of that out and using it as a standalone function, which is useful for a variety of different purposes. So as we'll see, join all, this little method here, is a wrapper that encapsulates the somewhat quirky all of functionality. So join all returns a single completable future to a list of t, whatever t happens to be. And you can see that we're going to pass in a list of completable futures to t, which I call flist for future list, as a parameter to join all. So you can see that join all is really converting a list of completable futures to a completable future to a list, which is kind of cool, because that's actually much more useful when all is said and done, because we have a single point to wait for all this stuff. Okay, now we're going to see some of the wacky all of syntax, which is wacky. So completable future all of wants to have an array. It wants you to give it an array that consists of all the various completable futures we want to wait on en masse. And of course, we have a list, because lists are a heck of a lot more useful to deal with for the most part than arrays. Arrays are somewhat crufty and weird in Java. So we have to be able to convert our list, our flist, our future list, into an array. So how do we do that? Well, what we do is we go ahead and we say, flist, turn yourself into an array. This is one of those methods that is provided by all the different collections in the Java collections framework. And we say, make the backing store for that array be an array of completable futures of size flist.size. So let's say we had 10 or 20 elements in our flist. So now underneath the hood, we're going to have an array of 20 elements which contain the contents of the list. So that's what that's doing. You can see why we're trying to build a wrapper around all this, because this is low level and somewhat crufty and weird. All right, so that's going to return to us a D future, which stands for, heck does this stand for? Maybe delayed future or future to handle, when it's done. I think it's called D is for done, the done future. So when this is done, right, when all of finishes all of its processing and all the completable futures are finished, then done future will become completed and triggered, and then we'll apply this code here. Now, this is kind of funky, so this is even more bizarre. All of returns a completable future to void. So you don't really know from the return value of all of what the types are that you're waiting on. Does anybody know? Does anybody want to guess why the heck it returns a completable future to void? This is even more bizarre. So all of, you can actually pass all of completable futures to many different types. So there is no single type. So you could have a completable future to integer, completable future to long, completable future to image, and you can pass them all into all of. So there's no way to say with certainty what the heck the particular type will be of any of the elements that are completed. So they punt, they just say, well, it's just void. So you have to figure it out. So luckily, in this case, it's easy to figure out. We go ahead and basically ignore what we get back here because it's a void, so it really has no meaning. And instead we say, when this future's finished, we're going to take the list of futures that came in the beginning, right? And we're going to turn that list into a stream, and now we're going to call completable future join. Completable future join is a method reference in this context, and we're going to call it on every element in this list. And the thing that's interesting about this is we absolutely know for sure that by the time we get to this point, that all these futures have finished. How do we know that? Because we never would have had the D future, the done future, trigger until all the futures were done, right? So this is purely for syntactic reasons, a syntactic necessity that we have to join all these things. They're already done. We just have to join them to get them from future to T to T, or future to element of T to element of T. So this is basically just converting the stream of futures of elements of T to elements of T. We collect all those things up into a list, which is now a completable future to a list of T. And the reason this is a completable future is then apply always returns a completable future. So this is a list of T. Then apply wraps a completable future around that list of T. And then we take that, so we have completable future to list of T, and we return that as D list for done list. So now we've got the done list. So what's going to come back from this is a completable future to a list of things that when that completable future, the D list completable future completes, everything in the list is ready and in the right format to go. Quite a mouthful, quite a lot of steps involved, right? Which, of course, is why you don't want to have to write this code, right? You do not have to want to write this code over and over again. You'd go insane. There's all these subtleties, and there's nonsense of dealing with the fact that completable future all of returns a completable future of void, and you have to create an array of the right size with the right backing store, and you have to be able to convert completable futures to elements of type T to elements of type T and turn them into a list. Way more than you ever want to have to think about. So we put it in a little class, or put it in a method in the class called joinAll, and now you just have to know how to call it. So it cleans it up quite a bit. So bottom line, this takes a very complex piece of code, right? The Gordian knot of completable future reactive join craziness, and it turns it into a powerful abstraction that shields you from the nightmare of all this stuff. If you want some more discussion about this, here's a guy, Thomas Nukowitz. I'm sure I'm butchering his last name. Great author on Java completable futures, and he describes this stuff in an article that you can take a look at. And there's more information he has here about completable futures. Okay, so that's basically the last